Let's look at a simple example. A man can row 8 km per hour in still water, and he finds that it takes him thrice as long to row up than to row down the river. Find the speed of the current. So the time upstream by time downstream is 3, thrice as long to row up. And we know that for the same distance, speed and time are inversely proportional. So time upstream by time downstream will be the same as speed downstream by speed upstream. This is 3. Now speed downstream we know is speed of the boat plus speed of the current. Speed of the boat minus speed of the current will be upstream, is 3. And the speed of the boat is also given as 8. So we have 8 plus current by 8 minus current is essentially what we are trying to find. Cross multiplying, it becomes 8 plus c is equal to 24 minus 3c. 4c is equal to 16. C is equal to 4 kilometers per hour. That is the speed of the current. Here's another example. A man can row 9 km per hour in still water. How far is his destination if the river is running at 3 kilometers per hour and it takes him 6 hours to row to a place and come back? So he has to go to a place and then come back. It could be upstream first and downstream afterwards, or vice versa. Doesn't matter. That's a river. And your current is flowing at 3 and he's capable of doing 9 in still water. So there are a couple of ways of going about this. One is to say, let the distance, let's say this is what he has to do, this distance. Let that distance be d, and the upstream time would therefore be distance by upstream speed, which is 9 minus 3. And then the downstream time will be distance by 9 plus 3. And the combined time is given to us as 6, which is basically d by 6 plus d by 12 is equal to 6, which is 12 in the denominator. 3d is equal to 6. That's d by 4 is equal to 6. D is equal to 24 kilometers. That's a straightforward equation based approach. What is given to us is total time is 6 hours. That's the sensible way to frame an equation. And then you solve with as few variables as possible. Just assume the distance, nothing else is required. One equation, one variable, you can solve this. Alternately, you can say that the downstream and upstream speeds are 12 and 6 from the given 3 and 9, which means they're in the ratio 2:1. So the time upstream, let's check this, time downstream by time upstream will be in the ratio 1:2. The speed ratio is 2:1. Time ratio is 1:2. So if it's a total of 6 hours, it should have been 2 hours downstream and 4 hours upstream. To find the distance, just multiply the 2 hours downstream with the 12 kilometers per hour to get the 24 kilometers. Alternately, you can multiply 4 hours with 6, you'll get the same result. But this is using inverse proportionality. If you're going for a paperless approach, I recommend the second one. It's faster. But if you're the kind who's not comfortable doing paperless and you're anyway going to write it, this is an easier explanation to understand, I suppose.